This lesson, we're going to be discussing the if statement. Okay, this is Learning Unit 7 on page 118 in the Prac book. So, for a program to be considered a programming language, it has to have three functionalities. It must be able to do three things. The first of those is sequencing. Okay, we call it sequencing. Basically, it just runs your program one line at a time from top to bottom. The second functionality it needs is what we call iteration, just a fancy word for looping. And we covered that in Learning Unit 5 when we did the for loop. Now, the third of these features, the third functionality that a programming language needs to be considered a programming language is what we call conditional branching. So that means we need a way to get our program to ask a question, and then based on the answer of that question, it follows a specific path. The actions it takes depends on the answer to the question. And if we've got those three things, we call it Turing complete, named after a guy by the name of Alan Turing. And that then defines your language as a programming language. That's why, for example, HTML, even though it's called hypertext markup language, is not a programming language because it's unable to loop and it's unable to do conditional branching. So it's not a true programming language. Okay, so here on my screen, you can see I've got an if statement there. Put it over here, and you can see it comprised of a couple of parts. You can also see this in 7.1 on page 118. We have the word if. Okay, there it is there. It must be written in lowercase. So in Java anyway, it has to be lowercase. And then we have a condition. There is the question that we are asking. Okay, so we are saying num mod 2. Essentially, num is just an integer here. You can see I declared an integer called num, and then I've inputted an integer from the keyboard. So num now is just holding an integer. So when I say num mod 2, you'll remember that the mod operator or modulus does integer division and then looks at the remainder. So it gives you the remainder of integer division. And because I'm saying mod 2, it means that there's only two possibilities here. Either I'm going to have a remainder of 0 or I'm going to have a remainder of 1. Okay, if the remainder is 0, I know the number is even. Okay, so this is a way in computer programming you can test if a number is even or odd. You just do mod 2 and then look at the remainder. If the remainder is 0, the number was even. And if the remainder was not 0, okay, something else, in our case, it can only be 1, then it's odd. So here's my if statement. Okay, so there's the question I'm asking. I'm saying if the mod 2 is 0, then I'm going to output the number is even, and then I've got an else part here. Okay, this deals with what if it's not equal to 0. Okay, so you've got an if and an else. So if that condition is true, then it does this, and if it's false, it does that. And remember, we need two equal signs in Java, right? Two equal signs in Java to test for equality. Okay, so that's an if statement. Okay, so we've got or an if else. Remember the else, this part here is optional. We don't necessarily have to have this part. It's only if we want to do something in case this is false, we give it some statements. We don't necessarily have to have the else part. It is optional. Okay, so if you look at the book on page 119, it shows you how to draw the flow chart, okay, the flow chart, the algorithm and the flow chart for that algorithm for an if statement. And you can see the if statement takes place inside of a diamond shape. You can see there, the question they are asking is the age less than 12? They obviously allowed someone to input their age from the keyboard, and now they are checking to see if it's less than 12. And you can see there are two ways out of the diamond. Okay, it's if it's true, yes, it is less than 12, whatever they added, whatever they entered in, then it takes the right hand path, and their price becomes 100 rand. So for younger people, the price is less. The tickets. Okay, this is a ticket thing. If the answer is false, okay, so age was not less than 12, so it was 12 or more, then it takes the false part out of the diamond and the price is set to 150 rather. And then later on, you can see it just displays the price and then the program ends. So that is the flow chart. That's what the flow chart looks like for an if statement. You must know that. Okay, so you must know how to draw the flow chart for an if statement. Okay, underneath that, they show you a pseudocode. So they're showing you pseudocode underneath that, and that shows you how to write an if statement in pseudocode. And you can see, and we've done this before for the for loop, there's a begin and an end. Okay, they actually literally write the begin and the end. Now remember, this is not Java code. This is not Java code we're writing. It's pseudocode. Pseudocode is kind of an Englishy representation of what your program is going to do. So you can see there in their particular program, they have a begin and an end marking the block of programming. Then they input the age. Then they check. Here's the if then else. Okay, so they are checking to see if the age is less than 12. And if it is, then they say that they assign the value 100 to the variable price. Else they assign 150 to price. And then they've got an end if. So they have got an if and an end if. There is no such thing as end if in Java. Okay, some languages indeed do have that. For example, PHP, if you program in PHP, there is an end if statement, but not in Java. But in pseudocode, that is how they are doing it. So you must know how to do an if statement in pseudocode. Okay, so you can just carry on following through the book there through 119. Then we're going through. Once again, have a look at that flow chart. Just have a look at activity 2 and see how they do the flow chart on page 121. Okay, so just work through these activities. Okay, I'm on page 124 on relational operators. Relational operators, you've seen these before for many years in mathematics. You've got equals to and not equals to, greater than or equal to, less than and less than or equal to. Okay, just take note how you write them in a Java statement. Okay, you can just read through the sections here on the important points in if statement. Done this before. Work your way through checkpoint 1. Work your way through activity 5. Okay, now we get to I'm on page 131. Okay, I'm just going to, before I get to there, I just want to show you something else here quickly in this piece of code that I've written. So here you can see, here was my if statement. There it is. Okay, so here's my condition, my first condition, checking for true. And then I've got bracket. Okay, remember brackets, squiggly brackets in Java they denote blocks of code. So I could put inside the squiggly bracket. I've only got one statement here, but there could be thousands of statements. It doesn't really matter. It could be millions of statements even. Okay, and the same thing in the else. Okay, so you can see I've got bracket there, and I've got blocks of code in there. Or in this case, I've got one statement. And because I've only got one statement, there is an easier way in Java to write this. And you can see I'm going to do it here. So this is an alternative method of writing an if-else statement in Java if you've only got one thing to do if it's true or false. So you can see here I've got if, and there's my condition. So if num mod 2 equals 0, And here's the one thing I want to do. Okay, system out print line, number is even. Else, and there's the one thing I want to do on the else. So you'll see I've got no squiggly brackets in there. And I can do that because I've just got one statement following the if and one statement following the else. So that is a sort of a shorthand method of doing an alternative if-else statement. Okay, so now we are going to have a look at what they call nested if statements. So a nested if statement, you can see I'm now on page 131, activity 6. So we are going to need a nested if statement if there are more than two possibilities. Okay, so you can see the example I gave you before this, there were only two possibilities. The remainder was 0 or the remainder was 1 because I did mod 2. But you'll see that like they in the book, they've given you an example there. They're asking you to enter something into the keyboard. And if you type in an A, they're saying goeiedag. If you type in an E, they're saying good day, obviously for English. And if you type in a Z, they are typing sawubona as a for Z for Zulu, obviously. So in this case, we've now got three possibilities: okay, an A, an E, or a Z. So a single if is not going to cut it here. We can't just do if else. Okay, so what we're going to do, and you'll see I've done here, in my case, I've asked the person I've taken the number that they entered, and I've got three possibilities. I've got this first possibility here is if the num, in other words, the integer they typed on the keyboard, if they typed something less than 100, okay, then I'm going to output this. I'm going to say number is less than 100. But I have another possibility, okay, so an else is not enough to cut it because I've still got two other possibilities. I want to check if the number is between 100 and 1,000 and if the number is bigger than 1,000. So I've got three cases here. Is the numbers less than 100? Is it between 100 and 1,000? Or is it greater than 1,000? And obviously I could have plenty of options. But in my case here, I'm just testing for three possibilities. So a single else is not going to cut it. So in the else, I've put another if, okay, with the last two possibilities in it. So there's the first if else there. So that this here is the first case right there, okay, to there. And now I'm putting in the next if else because I've still got two possibilities. So it says if numbers less than 100, print that. Else if the number is greater than 100 and, okay, remember two ampersand signs for an and numbers less than 1,000. So this is now checking to see if it's between 100 and 999. Okay, 1,000 is not in there because I didn't put an equals here. And if that is the case, then I get this number is between 100 and 99 and 999 inclusive. So I'll print that. The else is going to deal with the last remaining possibility because the number was less than 100. This looks to see if it's greater than 100 but less than 1,000. But what if I put 5,000 in? So I still have to cater for that possibility. Okay, if this here does it. The else will catch anything that is 1,000 or more. So this here is a nested if else. Okay, I will show you. We will do what we call later on in one of the following learning units. I will show you how to do a switch statement. A switch statement is much better at doing multiple possibilities. But here we've got three possibilities that we are dealing with. So a nested if is still fine for doing that. Okay, so I want you to have a look at on page 131. Have a look at the flow chart for that. This is what you want to do, and then on page 132, they are showing you what the modified flow chart looks like in an if else. Okay, so you can see there. The program starts, and then we've got the first diamond. As soon as you see a diamond, you know there's a question. So we've got option equals A, two possibilities, true or false. If it's true, we do the display and go to the end. If it's false, we move on and re-ask another question. Is the option equal to E? If it is, and we display good day and terminate. If it's false, we go on and look for another one. Is the option equal to Z? If it's true, then we display Sawubona and we leave. Otherwise, we just leave. Okay, so that there shows you how you have modified the flow chart, okay, for a nested if. Underneath that, they show you the pseudocode for a nested if. Okay, so you must know how to do that as well. So make sure you see exactly how that pseudocode works. Now you'll see that there are now three if and ifs. Okay, so there are, because we know there are three possibilities. So you can see the if and the end if is marking the start and the ending blocks in pseudocode. So on 132 and 133, page 133, you can see the two ways there of how pseudocode is going to work. Okay, I'm now moving on. I'm on page 135. Okay, 135, they start talking about logical operators. Okay, we've dealt a little bit with logical operators in the theory already. Remember, your logical operators are and, or, and not. Okay, those are your three logical. Well, there's more than three, but those are the three that we deal with here in grade 10. Okay, so you've got and, or, and not as your logical operators. Remember, the double vertical bar is or, double ampersand sign is and an exclamation mark is not. Okay, so those you can just work through that activity 8. Pretty self-explanatory there. They teach a little bit about how conditions are evaluated in Java. You can give that a look. Okay, Java uses what they call lazy evaluation. So if you've got something that says a condition A or condition B or condition C, remember that for an or, if you get a single condition that's true, the entire statement is true. So what Java does to be more efficient, as soon as it encounters a true in an or, it doesn't even bother evaluating the rest. Okay, because it knows the output is going to be true anyway. They call it lazy evaluation. Okay, so you can go through that. Remember logical operators, just like you've got BODMAS in mathematics. Remember, there's an order of precedence that logical operators are evaluated in. Okay, it's brackets first, then not, then and lastly or. Don't be scared to put brackets all over the place. Okay, so don't rely on the precedents to sort things out for you in your own mind. Brackets around things if you want it to be evaluated in that order. Okay, don't be scared to use brackets. In 7.6, they talk about negating the condition. So you can see you're saying if num less than 100, you could say if not num less than 100. So you can actually flip the question around to be the opposite way around. So you can just check that out there as well. We did De Morgan's law on the theory part. Okay, so if you had a complex condition, more than one part to it, then we would have to use De Morgan's theorems. Okay, you remember that? You break the line, you change the sign. So you would use De Morgan's laws for doing negation in that particular case. The last thing that I want to show you, that I want you to recognize, I'm now on 7.7 on page 144, and that is what happens if you end up in an if and it doesn't have a value. You've got to be very careful of that. So have a look at activity 11 there. You'll see that they've defined two integers, or they've declared them, okay, mark and mark of 10, and they've declared a grade of type char or character. And later on in the program, depending on what the value of markdiv is, they assign a grade. But you'll see that there's a bug in that program, because what happens if it was 0? You end up with grade not having a value because you didn't take care of all possible eventualities in your if else. So that's one thing you've got to be careful of in an if else, is that you cater for all possible eventualities. In this case, we're lucky that NetBeans is going to realize that, and it's going to warn you. Okay, so the compiler is going to throw you up an error, not when it compiles, but even before that, saying be careful. There is a possibility that you are leaving a a variable dangling with no value. So just keep an eye on that. That's something you've got to be very careful of. Okay, so that's it for if statements. Okay, just work your way through the book, go through all the checkpoints, exercises. Obviously, it's crucial that you know how to use if statements. It's one of the three pillars of programming. Okay, so if you have any problems, then give me a shout.